Number 11, what is the shape of a cross section? So the cross section, what that means is if we were to slice our polyhedron with a plane, so if you were to slice this here, insert this plane, and then you basically took your shape apart right there, what shape would that make? The intersection of the plane and your polyhedron. Well, you can see the outline right here in red. That outline is your cross section. That's the intersection of your polyhedron and the plane. So here, the shape of the cross section would be, looks like a square, but we're not sure if it's a square, so we will say a rectangle. So let's take a look at B. If you see this plane, it's slicing this cone, and it looks like it's slicing it in half. The shape of the cross section, or the intersection of the plane and the cone, and you can see it right here, is a triangle. So not bad, that's an easy question. Number 12, find the height of a right cylinder with a surface area of 160 pi and a radius of 5. So let's go ahead and just write the equation for surface area. The equation for surface area is 2 pi RH plus 2 pi r squared. And they told us that the surface area is 160 pi. So I'm going to go ahead and plug that in right here. And they also told us that the radius is 5. So r will be 5. We don't know the height, but we do know the radius. Notice once I've plugged all of this in, my only variable is the height. So I can solve for that. I'm going to first start off by simplifying everything I have. Let me divide by pi. If I divide by pi, all of these will cancel. So let's just go ahead and get rid of them. So now I'm left with 2 times 5, which is 10. And then the h variable is still there. 5 squared is 25, and 25 times 2 is 50. And then over here we still have 160. So from here, this is just an algebra 1 problem. We can subtract 50 to both sides, and I get 110 is equal to 10h. Whoops, too fast right there. And then we're going to divide by 10, so we get that the height is equal to 11. And that's it. We found the height, which is 11 feet. And if you always want to check during the test, plug this back in and make sure that this equals 160 pi. So problems like this, you can always go back and make sure that your work is correct. Number 13, find the height of a right rectangular prism with a surface area of 286 meters squared and a length of 10 and a width of 8. So this time we have a rectangular prism, and we're given the surface area. So the equation for surface area is capital P, so perimeter of the base, times the height, plus 2 times area of the base. So now we have to think, if this is a rectangular prism, then the base is going to be a rectangle. So in order for me to find the perimeter of the base, we're going to do length plus width, right? Because we have 4 sides of that rectangle. That'll be my perimeter of the base. And then we have our height. And then 2 times the area of the base, so you got to think again, the area of the base will be a rectangle. So in order to find that, I'm going to do length times width. So over here, I'm just showing all the variables of what it is that I'm doing. I was told that the surface area is 286, so we can put that in here. And now we can go ahead and substitute everything that we know. We're asked to find the height, but we do know the length, and we know the width. The length is 10, so that'll be 10 plus 10. And then the width is 8, so we'll have 8 plus 8. We don't know the height, so that'll be our variable. And then over here we have 2 times 10 times 8. Okay, so we have our length and our width. Let's simplify this so we don't have a lot. We have 10 plus 10 is 20, plus 16 is 36 times the height. And then over here, 10 times 8 is 80, times 2 is 160. So this is equal to 286. Now this is algebra. We're going to subtract 160. This gives me 126. Well, it's not a pretty 6. There we go. And we're left with 36h on the right side. And we're going to divide by 36, and then we will have our height. So the height is equal to 3.5. Number 14, find the total surface area. The cone shape is cut out of the cylinder. So this right here is hollow. This is not here. So we want to find the surface area. Now remember, the surface area is the part that you can touch. So this cone is out. That means I can touch this part of the cone, but there is nothing up here. So let's start off first by finding the surface area of this cylinder. So surface area of the cylinder, the equation is 2 pi RH plus 2 pi r squared. Now I'm not going to write 2 pi r squared because if you notice, pi r squared, this is the equation for area of the circle. So that's meaning it's going to take this area of the circle right here at the base and then this area right here. Well, I don't want this area right here because it's cut out. That cone shape is not there. So instead of adding 2 area of the bases, I'm only going to add 1 area of the base. And that'll give me the surface area. That's the part that goes here around and this base. So that's why I'm not putting that 2 there. Can you put the 2 there? That's fine. You're just going to have to go back and subtract the area of the circle. So here, the radius is 6 and the height is 10. So we have pi, radius is 6, and squared. Okay, so the surface area of this cylinder ends up being 156 pi. And I'm going to leave my answer in terms of pi. You don't have to, but I'm going to just so that I can avoid the decimals. Now, I have to include the surface area of the cone. I can touch this rounded part of the cone. I just can't touch his base. So since I can't touch the base, then I'm only going to compute the lateral area of the cone. So the equation for that is pi r times your slant height. So we know that the radius is 6, but we don't know the slant height. That's right here. We're going to have to use the Pythagorean theorem here with this right triangle so that we can find the slant height. So we'll go ahead and outline this so you guys can see where that right triangle is at. We do know that the height is 10 right here, and we know that the radius here is 6. So do Pythagorean theorem, and I'm not going to go ahead and do that because I know that we all know how to do that. And we get the slant height is about 11.7. So now we can go ahead and plug that in, and we get that this is 70.2 pi. So now the total surface area, we're going to have to add this surface area and this one right here because this is the part that we can touch. It's on the surface. It's on the outer part. So I'm going to put here S with the little t. The total surface area will be 156 pi plus 70.2 pi. And that ends up being 226.2 pi. Now, if you don't want to leave it in terms of pi, that's fine. You can just multiply by pi, which ends up being 710.6 about. Number 15, find the total surface area and volume. So notice surface area is only the part that's on the outside. It's the part that you can touch. I cannot touch these bases right here. So that means that on both cones, I'm going to solve for lateral area instead of surface area. So the lateral area for the cones require the height. So let me go ahead and calculate that right now. The height would go right here for this one. This makes a right triangle. And then this one, once again, also creates a right triangle. We're going to use Pythagorean theorem to do that. That gives me that this, if we round, is about 23. And then this one is about 15.5. Alright, so we have our height. I'm going to do the lateral area of this one on the left side, which is pi times your radius times L. The radius is 7, and the slant height is 24. So here, I'm going to leave it in terms of pi. We're going to do 7 times 24, and that gives me that the surface area is 168 pi. Now here on the right side, we'll do lateral area, and we'll use this right here, pi RL. We take pi, our radius will be 7, and the slant height is 17. So 7 times 17, we're going to leave this in terms of pi, is equal to 119 pi. So my total surface area will be the sum of these two. We're not including the area of the base here because it's not on the surface. So 119 plus 168 is equal to 287 pi. So you don't have to leave it in terms of pi. You can leave it as a decimal form if you want. Just multiply by pi. Now we're going to do volume. Volume of the cone on the left side is area of the base times the height divided by 3. And we've already found the height. We did that at the very beginning. The area of the base is pi times your radius squared. So 7 squared. This is the area of the base. And we're going to multiply that by the height of the cone, which is 23. Then we're going to take this and divide it by 3. So the volume for this cone on the left side is about 375.7 pi. So here I'll even put a little L here for the left side. And now we're going to do the volume of the cone that's on the right side. We'll put a little R here to represent the right side. Same equation, area of the base times the height divided by 3. So the area of the base is pi times your radius squared times the height of your pyramid, which we found that was 15.5. I'm sorry, that's a cone. And we're going to take this and divide it by 3. So the volume for this shape is 253.2 pi. Let's go ahead and get our total volume, and I'm not going to fit it here, so we'll just put it right up here. V, and then we'll put the little t so it represents our total. We're going to add this number and this number, and that ends up being 628.9 pi. Oh, the pi is barely going to fit there. There we go. Okay, so always make sure you know for surface area and lateral area whether you need to include the bases or not include the bases.